bill is too expensive. This is because this month of the bill is too expensive. It is because of you because you did not switch off the light.
How could I know that I forgot to switch off the light and increase the bill?
You should know.
That will be great if we have system that can monitor our electricity in our house.
Great idea.
Project focused on developing a low-cost IoT smart meter with AI load identification to help users monitor and manage their electricity usage more effectively. Current smart meter usually show only total energy consumption and do not identify which appliance use most electricity. Because of this, user may find it difficult to control their energy usage and reduce waste. To solve this problem, the project trusted load monitoring (NILM) and machine learning (TinyML) using an ESP32 microcontroller and PZEM0040 sensor. The system can analyze the power data from a single sensor, identify active appliance, monitor electricity usage in real time, estimate billing, and allow remote monitoring or control. The purpose system is affordable, easy and use and suitable for home automation. It supports smart energy habits by helping users understand where electricity is being used and take action to reduce unnecessary power consumption.
Problem statement. There are three major factors that current residential electrical system face on which impact their effectiveness in promoting energy efficiency. First, traditional meter only show the total of electricity has been used. They cannot distinguish which appliance is consuming the most energy, especially when different devices have similar power levels. They cannot know where energy has been wasted. Second, advanced techniques such as combinatorial optimization (CO) and factorial hidden Markov model (FHMM), making a high-level processing power level, making them not suitable for low-cost and AI-based deployment. Third, while IoT monitoring system exists, few integrate real-time or remote control functions that enable users to switch their appliance when they cannot be present physically.
Three objectives for this project. First, to build an IoT smart meter with AI model capable of load identification with more than 90% accuracy, real-time energy monitoring, and remote control of an ESP32 microcontroller. Second objective, to simulate the functionality of smart meter like load identification and real-time monitoring using Proteus. Objective and the last one, to evaluate the performance of the system in terms of accuracy and response time of load identification, real-time energy monitoring, automatic high usage alert, and cloud logging.
SPARC is an IoT-based system designed to help users monitor their electrical energy consumption in real time.
At its core, the system uses the PZEM0040 sensor to accurately measure the key electricity parameters such as voltage, current, power, and energy consumption. The ESP32 microcontroller serves as the brain of the system, since it handles the data processing and enabling wireless connectivity through Wi-Fi.
For appliances control, the system includes a relay module, which acts as a switch to turn devices on and off as needed. The Blynk mobile application provides a user-friendly interface for remote monitoring and control, enabling users to access the system from anywhere via the smartphone. As I turn on this electrical socket, SPARC system will continuously monitor the electrical consumption in real time. Total consumption also can be seen in the Blynk. For the remote control function, how we control this lamp by turning it on and off by just using virtual switch on Blynk apps. Similarly, I can control the charging of this laptop remotely by just using virtual button on Blynk app. Next, SPARC also have notification feature which send automatic alert when the total consumption of electric has exceed the preset threshold. The consumption threshold can be adjusted according to customer need by using Blynk app or Blynk platform on laptop. Last but not least, SPARC system also automatically record the consumption data and log it into Google Sheet for further analysis.
This process is started by collecting the electrical data from the several household appliances using the PZEM0040 sensor. This sensor will be measured some of the important parameters such as voltage, current, power factor, and also the frequency. The appliances tested including the laptop charger, the table fan, hairdryer, and no load condition. This data is collected with the sampling rate of 2 Hz, which is very suitable for the general household load identification. After the data is collected, so it will display the raw data graph here as what we want. So we have the voltage, current, power factor, and also the frequency. After that, after we done with the process, so we will have the DSP result and the filter response. This is the filter response before, this is the after the filter. And also we can see the successful of accuracy for our model by looking at this confusion matrix. So this is the step where we can see it is 100% accuracy of our training and only loss of 0.2. So for the data explorer also, we can look at this part. So we have the correct of the accuracy data acquired from the system, which has the sampling rate of the 2 Hz. So this is the AI model that we use to train our data that is using the edge impulse.
Based on the prototype testing, the AI-based load identification achieved an overall accuracy of 95%. The system successfully identified several loads including laptop, table fan, and hairdryer. For system response, the relay switching time was below 500 milliseconds under strong Wi-Fi condition. The AI load identification response was below 2 seconds under strong Wi-Fi. This result showed that the system is functional, responsive, and suitable for real-time energy monitoring.
Traditional method that only shows the electricity usage. This project shows the combination of provide the real-time monitoring and AI-based load identification to help users understand which appliance consume energy.